All right, let us begin. So today we're doing CSEC past paper, mathematics, May 2024. All right. So the first question says what we want is to calculate the value of square root 7.1 square plus 2.9 square, given your answer to the correct two significant figures. All right, so first and first, we're gonna take out our little calculator. And we're going to put it in, and your answer should be the calculator. Plus it should be 7 point. Should be 7.6. Should be. So this is our answer. So 7.6694, and it continue. So what they're asking us right here is for the two significant figures, and we know that 7 and 6 is two significant figures. 7 point, and when we round off, it's going to be 7.7. And now it's asking for two decimal places, so it's going to be 7.6. And we're going to round off the last decimal place to 7, because it's two decimal places. Moving on to question number, the same question. So here we have, write the following quantities in ascending order. So the first thing we're going to do is convert these quantities. An easier way to convert it is into percentage. So everything can be in percentage. So we know that 12 over 25 times 100 would equal to 48%. So that's our 12, and we know that 0.46 is equal to 4.6%. And we know that 47 is 47%. So based on that, ascending order means from least to greatest. The least we start off with would be 0.46. So you want to write back the same quantities they gave you. And then we have 47%, and then we have 48%. That's the quantity. Yes, it's 12 over 25. All right, moving on. All right, and we have now here Mahendra and Jane shares 7,224 in a ratio 7 to 5. How much more money does Mahendra receive than Jana? Now, in that, we're gonna use the topic proportion and ratios, where we're going to add the 7 where we're going to add the 7 and the 5 first, which give you 12. And then you subtract the 5 and the 7, you give you 2. So we know how much more money Mahendra received. She get 2 more than Jana. So we're going to put 2 over 12 times 7,204. We'll put that in the calculator. So 2 times the 7,004 and then divided by 12, you get 1,204. That's the answer there. And moving on. And then we have the present population of Portmore in 550,000. It is expected that this population will increase by 42% by the year 2030. All right, so you say write the number 550,000 in standard form, and we know that the standard form formula is A times 10 to the power. And A represents a number between 0 and 10. So it is going to be 5.5. So that's number between it. And then 10 times n. N is how much spaces you move to get to this. So we have 1, 2, 3, 4, 5. So 5. So our answer is 5.5 times 10 to the 5th power. Moving on to the next. All right, so it says calculate the expected population of Portmore in 2030. All right, so we're going to do percentage of quantity, where we know that around the next side, we see that it says 44% increase. We say 44% increase in the year 2030. So what we are going to do is multiply our figure, which is 5 which is 550,000 times the percentage, 42%. And we know that 42% is over 100. So what we can do right here, is cancel out the zeros. That's cancel 2 zeros out of here. And then just use your calculator and multiply the 42. And what is left over here? And the answer will be 42 times 5500 equal 231,000. Moving on next. All right, so it says the graph below can be used to convert between the United States dollars and the Eastern Caribbean dollars. So in that, I'm going to ask you to use the graph to help you. As it says, using the graph, convert US dollar to EC. Now, in this graph, the only thing that makes sense here is when two lines meet or two numbers meet. So right here, so right there, the two lines meet. So it's 3 and 8 meets. So we can say that $3. So in the graph, it's a 3 US dollars equal 8 EC. There we go. So using that now, I can find out how much is for $1, 1 US dollar. So I'm going to find it. So now 1 US dollar I got equal to 8. I'm going to put the top number on top and 3 at the bottom. So 8 into 3. Can we use our calculators again? That's why it's very important to get your calculators and get used to the calculators. Because if you buy it at the last minute and you don't understand your calculators, can cause you to fumble. And then that round off. So $2.67. So we're not finished yet because we still need to know how much is $2. So what we're gonna do here now for the $2, multiply the number we get for $1 by 2. So 2.7 times 2. I'm gonna use our calculators again. We're gonna multiply by 2. And we get $5.34. And that's the answer there. All right. Moving on. We're still in converting the EC 70 to the US dollar. So based on our calculation over here or so, we found that 1 US dollar equal 2.67. We're going to use that same method again. So let me write it back here. So since 1 US dollar equal 2.67 EC, we're going to now divide $70. So the bigger number on top, there's the number on the bottom, divide that out. We're going to go back to our calculators and figure out that number. So 70 divided by 2.67, that'll be 26.22. That's our money there. So that's our US dollar. We can leave it as is, or we can just write US just to, make it have a little flair. We're gonna move on. All right, so this one now has to do with both algebra and knowledge of. All right, let us read first. Let's see what they're asking for. It said Lauren needs to push a mesh around 2 seed bed to protect her seedlings. Altogether, she used 60 meters of mesh. One of the seed bed is a rectangle and the other is a square. As shown in the diagram below, you see that the seed bed, two seed bed, one is a rectangle, one is a square. The width of the rectangular seed bed is X meters. The length of the rectangular seabed is 3 times its width. The length of a square of the length of a side of the square seabed is y meters. A, use the information given above, derive a simplified expression for y equal terms of x. All right, so we're trying to find y equal in terms of x. So that means I have to use both information from the seedbed, rectangle seedbed, and the square seedbed. Now, based on our understanding over here, it says first, if put the mesh around. So we know that around means perimeter, right? Around means perimeter. And altogether, she used 60 meters of mesh. So basically, Lauren just have 60 meters of mesh only, and she used it for both of them. That means out of the 60 meters was accurate around the rectangle and the square. So first thing first, you go find the perimeter of the rectangle. So the rectangle, right? The perimeter of rectangle. So we, based on our information, so the width is x, right? So and we know that a rectangle have two sides, two widths, and the length of a rectangular seedbed is 3 times the width. And we know that that is 3 times x. Good? There we go. So in our perimeter, we add up everything. And that's going to equal to what? What does that go equal to? All right, so 3, 3, 6, 7, 8. So that is 8x. Now we're going to the square. Using our background, we know that the square have all 4 sides equal. So everything just equal to y. So we know that is 4y. So we're going to put these two together now and see. Eight x. Hold on there. Give me a minute. Because we have not yet simplified. So we're going to say 8x. Why am I writing y? 8x equal, not equal. 8x plus y plus 4y equal the 60 meters, right? The 60 meters of mesh. So we have to simplify it. So in terms of y. So that means y has to be the subject. So if it says simplify in terms of y have to be the subject. So I am going to bring over everything away from y. So the 8x are going to come over here. We know that when it's positive over here, when it comes over here, it will be negative. So 4y equals 60 minus 8x. All right. And then the 4 now, since it's multiplying the y, we're going to divide the 4 out of everything. 4 divided by 4 divided by 4. So cancel out. So that leaves y equal 4 into 60 is what? About 15. And then 4 into 8 is 2x. And there we go. So please make, so that is the simplified expression for y. All right, moving on. All right, so B. BSA is still we're doing with the rectangle. So the area of the rectangle seedbed is equal to the area of the square seedbed. Use this information and your answer in A to write down an equation in terms of x and show that it's simplified to x squared minus 60x plus 225 equals 0. All right, so first thing first, rectangle. Go back and see how my rectangle look like. Rectangle says 3x and x. So we know how area of rectangle is length times width. So it's gonna write 3x times x, and you say equal to the area of the square. So the area of the square, formula states y square, right? So y square, and that's the formula. So 3x times x is 3x square, and then y, based on what we did over here now, y was what? Y was 15 minus 2x. Right? You seeing it down here? And that's what we came up with. So 15, so I'm gonna bracket. So 15 minus 2x, not y, 2x. And all of that square. All right, so we're gonna start expand on the y square. So we know that when we expand 15 minus 2x, it looks like this. I will put it in distribution form, right? And then we start distribute out. You know, 15 times 15 is let's put that into the calc. No, we don't only need that. 225. 2 times 2x, negative 2x times 15 is negative 30x. And 15 times negative 2x, same thing, 30x. And then negative 2 times negative 2 is positive 4x square, and everything here so equal to 3x square. Now it don't look like the formula up here, so as yet. So I realized that the equation must equal to 0. So I am going to first carry over the 3x over the other side. So when we carry that over, here's going to equal to 0. And since 3x squared is positive, when you reach over here, going to be negative. So negative 3x squared. So you combine the like terms, you know that negative 30 minus 30 is 60. That negative 60x. And then 4x squared minus 3x are going to be, well, positive x squared. Everything here is equal to 0. So now you can see, say, same thing. So let me rearrange it so it looks like the same. So, yep. Well, you can leave it as it right there because it is the same. Because you can still see from here. You see what my pencil is? From here, you have x squared, and down here I have x squared minus 60 plus 225, and everything equal to 0. All right. Give me a minute. All right, moving on. Okay. All right. So it says solve the same equation using a quadratic formula. Now, the quadratic formula will be this. Right? I don't know if you guys remember. It's x equal negative b plus minus square root of b squared minus BAC over 2a. Make a note of that. So that is the quadratic formula. But for your convenience, if you don't remember, you can go straight to the first page, the what's it called again? The formula page, and you can find it right there. CSE make it so easy for you. So if you cannot find it, if you don't remember it by heart, you have it in the list of formula. And you can find it under roots of quadratic equation. Right? When a quadratic equation equal to 0. So it is a x squared plus b x plus c equal 0. All right, so a is 1 according to the formula right here. A is 1. B is what? Negative 60. And C is 205. All right, so based on that now, let us plug it in. So x equal negative 60 plus or minus negative 60 square minus 4 A is 1, C is 205. So let us square root over 2A, which is 2, 1. All right. All right. So let us do it. So, um, so as you can see, this is a negative sign. So x gonna equal to 60, because negative and negative gives 60, plus or minus square root of this up here. So we're gonna go back to our calculator and we're going to square root everything. So in my calculator, I'm pressing square root, bracket, negative 6 square, negative 60 square, subtract 4 times 1. Well, you know that's a 4, so times 225, and then close it with a double bracket. And my answer should be 5.51. So 551.96. All right, over 2 times 1, 2. So I am going to separate it now. So right here it says plus or minus. So that means I'm going to first over here, I'm going to plus 6. Oh, and divided by 2. So I'm going to put it in my calculator. 60 plus 551.96 divided by 2. I get 55.98. Then I'm going to come over here and then subtract it. So 60 subtract 5, 1.96 over 2. And that's going to be divided by 2, 4.02. So x is going to be 55.9 and 4.2. And that's how we solve it. So all you have to do is just plug it in the formula according to the formula. All right, we're not finished yet. We still have to calculate the total area of the two seabed. So, all right, calculate the two areas, two seabed. So since we know that so the area of two seabed. Since we know that, let me go back for a while. Hold on. Since we know that right here it says the two area equal each other, right? I can use one of these formulas right here. So either 3x squared or the 15 minus 2x squared. Now I'm gonna use the 3x squared. And that's much easier. So I'm going to, so 3x squared, and it's two of them, right? So I'm gonna multiply that. So 2 times that to be 6x squared. And then I'm gonna substitute the x for 4 point. What we did over here for the one of these x. So I'm gonna use the 4.02. So 4.02 and see what we get. So we're gonna go back into our calculator, times that, and we get about 24.12. Oh, hold on, I forgot to square. All right, so that answer my correct then. So 4.02 square is not this. So it would be 96.96, and I can leave it as that. Somebody in the chat said, hi, Raheem, welcome. All right, so that is the last of number 2. All right, so we're going to move on to number 3. A vertical flagpole, FP, stands on a horizontal ground and is held by 2 ropes, PG and PR, as shown in the diagram below. PG equal 18 meters, FR equal 9.7 meters, and angle FGP equal 38 degrees. So it's asking you to calculate the height of the flagpole. So as you can see right here, it's a bunch of triangles that is made up. And we need to find the height of the FP. So FP is right here. Based on this now, this looks like a right angle triangle. So we're going to use the Pythagoras. Going to use trigonometry, basically. So because we only have, the reason why we're using trigonometry is because we only have one side and one angle. If we had like 2 sides, we could have used Pythagoras, but since we only have one side and one angle, we're gonna use trig. So in order for me to remember my trigs, I always use this to help me. So katoa, and I find out which angle I have. So I have the hypotenuse, the H here, and the PF is my opposite. So I'm gonna use sine. So it's S is the sine, theta equal opposite over hypotenuse. So I'm going to make my opposite my subject. So opposite is going to equal to sine theta times hypotenuse. All right. So we have sine 38 degrees times the hypotenuse, which is 18 meters. All right, going back to our calculators. Type in sine 38 times 18 give us hold on there. All right, so I got 11.08 meters. Mhm. That's what I got. So going on, moving on. All right, so it says find PR, the length of one of the piece of rope used to hold the flagpole. So let me go search for PR. Where is PR? PR is right here. So we already know this is 11. So PF is 11. And now we're finding PR. And just like what I said, we now have it's a right angle triangle, and we now have two sides, right? We have two sides given us to us, so we're going to use the Pythagoras theorem formula, which is C square equal A square plus B square. So that's the difference. So go back over here. When you have only the angle and one, you use the trigonometry. But if you're given or you find two sides and they tell you to tell me the unknown for one, use the the Pythagoras theorem formula. So our C is unknown. So I leave that blank, right? And then we know A is what? A can be the longest side, which is 11.08 square. And B will be 9.7 square. Okay, so let us add that up in your calculators. All right, so that is about 216.85 or 86. And then we're still looking for C, so we're going to square root everything here. So that is C, and then square root the 200. And 16.86, we get about 14.73. All right, moving on to B. In the diagram below, PQ is parallel to MN, and LRT is an isosceles triangle. And SLT is a straight line. All right, so let us see what it says. Find the value of X. And X is up here. All right. So what we're gonna do now, so they say it's an isosceles triangle. So isosceles means the two sides are equal. Good. Mm-hmm. LRT. Yes, the two sides are equal. So those sides are equal, and they said P, Q, and M, N are parallel. And then when they say parallel lines, we can do the alternative line or the Z part right here that says that when right here will equal to over here. So that means this side will equal to 28. Good. And same with the parallel lines. Corresponding angles will be equal. So here, everything here from this side to that side will equal to X. Okay. And we know that this is a straight line. And a straight line is good. So right here is a straight line. Good. So that is out of a 80, 180. One straight line is 80. So I'm going to subtract it by the 28. And then since we know it's cut by the ST, I'm going to cut it by 2. Let's see if we can get the answer. Or to find this, basically. We're going to find this part. No, sorry. We're going to find this part. Right, so we're dividing by 2 to find that part. So 180 will be about divided by subtracted by 28 will be 152, and we divide that by 2 will give you 76. So X is gonna be equal 76 plus the 28. So that will be equal to what? 104. So X equal 104. All right. All right, so let us go. Next one. The diagram below shows a square T and its image Q after a transformation. Describe fully the single transformation that maps shape T onto onto shape Q. So this is T and this is Q. All right, so looking at it now, we have to go down the line of transformation. So it did not enlarge because it did not get smaller or bigger. So that is out. Did it reflect? Yes, it did. It looks like a reflection because it looked flipped. Right. And it does look like a reflection. So in that said, since we have identified that it is reflection, so we need to identify the mirror line. And the mirror line looks like it's from right here. right? And what kind of line is this part? It will be y equal x. Because it's mapping on to each other. So 1 map onto 1, 2 map onto 2, 3 map onto 3. Yeah, so y equal x. So it's a reflection. And the mirror line is y equal x. That's all it's asking you to do. 2 marks and it's done. Next one, it says, on the diagram above, draw the line of T, shape T, if it undergoes a translation by the vector -1, 6. Label is image M. All right, so moving from shape T to image M. We use a different color so we can. All right, so use a different color. All right, so we're moving by the vector -1 and 6. So -1 is on the x-axis. So negative means moving to the left. So we're going to move 1 space to the left, and 6 represents y-axis, and +6 mean going up. So we're moving upward 6 times. 1, 2, 3, 4, 5, 6. So right here. Then we're going to do that for every angle now. So moving 1 space across and going up 6 times. 4, and that is 6. 1 space across and moving up 6. Right here. Moving 1 space across and moving up 6. All right, so let me use a different color to draw my image. So across this way. Oh, give me a moment. Let me see if I can use a ruler. Let me erase this. See if I can use a ruler. Okay, a line. So here is my line. So it's going to be my y-axis. Change the color. This is going to go up. Right here. Wonder if I can find a broken line. Yeah. All right, so the broken line is not working out, but you get the gist. Okay. 1, 2, 3, 4, 5, 6. So going on here. And going across here. I'm going straight down here and going across over here. So that is moving one space to the left and 6 upwards. And that is M. There you go. All right, skipping. All right, so number 4, it says a rectangle PQRS has a diagonal of PR, where P is the point -3, 10, and R is the point 4, -4. Calculate the length of the line PR. And we know the formula for length of a line should be x equal square root of y, second y, square plus first x minus second x. All right, so that is our formula. So you can choose which one you want. Just make sure that it says constant. For example, P, if P should be the first x, then the y must be the first y. So let's do it here. So y, first y is 10 minus -4 all squared over x -3 minus 4 squared. All right, let's use our calculators or our mind. 10 -4 gives us 14 squared. -3 minus minus 4 will give us about 1. No, wait, not 1. -7. Ooh. And that is square. And we know that 14 square is about 6. Subtract 49. So let's subtract that. Can't forget our square root. And we get 147. And what's the square root of 147? 12.12. That's it. We can't forget our units. Mhm. All right, moving on. Determine the equation of the line. We know that the equation of the line is ymx plus c. All right, so did we find the m? And did we find what? C. Was it in the m is the gradient? Okay, we did not. We did not find it. So let us find it first. So let us find what is m. The formula for the slope or gradient is always rise over run. All right, rise mean y. So it is 10 subtract -4 over run, which is all of the y's, all of the x, sorry, with -3 subtract 4. So we know it is 14 subtract 7. Over 7 give us 2. So our medium is 2. So now we need to find what C is. We know that M is 2 plus C. Now I can use the points given to me to represent Y or X. Either I choose P or R. I am going to choose R. So Y is going to equal to -4, 2, and X is going to equal to 4 plus C. So we're finding C. So this is -4 equal 8 plus C. I'm going to carry this over. 4 -8 equals C. So C equal -12. And then I'm going to put this all in one now. So it's Y equal 2x subtract 12. And that is our equation of line PR. Right, next, we have two functions f and g are defined as follow. Fx equal 3x plus 1 and gx equal x squared. Find in the simplest form an expression for f of x minus 2. Now, this should be the easiest part, or one of the easiest part. I love this very much. All I have to do is plug in wherever x is in the f equation, which is 3, which is this one. So it's going to plug in the x minus 2 plus 1. So we're going to use some distributive. I know that x times 3 give you 3x, and 3 times 2 give you 6 plus 1. And that's going to equal to 3x, -6 plus 1 give you -5. The answer is 3x minus 5. All right, moving on. All right, so this is G, X, G, I'll map onto 3x plus 2 plus 10. So first and first, I need to use back the formula right here. G map onto x equal to x squared. So I am going to put wherever x is, I'm going to put where 3x plus 2 is. So that is going to be 3x plus 2 squared. Then I'm going to plug this in now in the equation on top. So 3x plus 2 squared plus 10. And then I'm going to expand. Do some distributive. So we know 3x times 3x is 9x squared plus 6x. And then 2 times 3x, 6x again. And then 2 times 2, 4 plus the 10. And then I combine the like terms. 9 squared is by itself. 6x plus 6x, 12x. And 4 and 10 is 14. And that's our answer there. All right, moving on. Oh, this should be 0. This should be 0. I'm supposed to look at that. All right, 0. Look more of a 0 now. All right, moving on. Number 5. All right, so we reached number 5 out of 9 questions. That is good. Mr. Morgan administered spelling test to his class. The table below shows the number of words out of 10 that each student spelled correctly. For the data shown above, state the mode. So the mode is the most frequent. So right here, we have to look at what's the highest number in the frequency. That is 8. So the number of words is 5. So the answer will be 5 words. Remember, mode means most frequent. No, it asks us to find the median. And this is a frequency table. That means I would have to add up everything in the frequency table. All right, so 8 plus 4 is 12. 12 plus 2, 14. 14 plus 2, 16. 16 plus 3, 19. 19 plus 4, 23. So our formula is N1 divided by 2. So N is 23 plus 1 divided by 2. That is 24 divided by 2 gives us 12. So our median is in our 12th position. And our 12th position is at right here. Because remember, 8 plus 4 give us 12. So that means 6 words. So 6 words is the median. So 6 words is the median. All right, skipping on. All right, so it says calculate the mean number of the words spelled correctly. All right, so I'm going back over here and I am going to calculate the mean. Now, in order to find the mean of a frequency table, this is our formula, mean equal total over n. So based on over here, our n was what? 23, right? So now we have to multiply the number of words with the number of frequency. So the first one was 5 and 8. 5 times 8. Next one is 6 and 4. And I put an addition sign. The know that is total we're finding. 7 times 2. 8 times 2. Oh, 9, 3, 10, 4. 9 times 3 and 10. Ooh, 10 times 4, right? I put 10 times 4. And then all of that divided by 23. All right, so we're going to put everything here in our calculator and see what we get. I mean, everything on the top numerator. Times 4. 7 times 2. 8 times 2. Plus 9 times 3. Plus 10 times 4. All right. I got 161. 161 over 23. And we divide that out. And I get 7. So our mean is 7. All right. Let's go. Next one. The attendance officer at a particular school recorded the time, T, in minutes taken by each student in a group to travel to school. The data collected is shown on the cumulative frequency curve below. Using the cumulative frequency curve, find an estimate of the number of students who took at most 32 minutes to travel to school. All right. So let me get my my line. So we're at 32 minutes. So 32 would be basically right here, right? So I'm gonna make it long. All right. And then wherever it stopped on this line right here, I'm gonna put it this way. All right. So I can say it's between 40 and 60, but a card, so I can write that, I can write so it's between 40 and 60. So between 40, right between 40 and 60. And 60, or I can use up my physics skills or biology skills, wherever you got that skills from, and divide these up because they already give you grid papers right here. And I can say that about 1, 2, 3, 4, 5. There are five grid between 40 and 60, and that is 20 divided by 5. So each grid right here, these little fade out grid, would be divided. So 40 and 60, you get 20. You divide the grid papers, grid fade out grids by 5. And you know that each fade out grid is 4 points. So I can say this is the first fade out grid is 44. Next one is 48. And the next one is going to be 52. So I can say that it is at 52 for those who want to be more specific. All right, next one, the interquartile range. And that formula is about very easy to remember. It's just same thing like a range. Quarter 3 minus quarter 1. All right. So based on its name, quarter, we know that quarter 3 is going to be 3 over 4 times the highest point, which is 220. Hold on, let me see if I can make it smaller. This is going to take a little more time. So let me put it over here. So we have 1 over times 220. And over here is 3 over 4 times 220. So this is the first quarter and this is the third quarter. So first quarter is going to equal to how much? Let's put it in the calculator. Quarter of 220. Second would be 55. And third quarter will be 165. All right, so based on that now, I am going to use my lines to match up. So 55 will be basically somewhere right here. So remember when I was telling you one of these lines means 4. So because if 52 is right here, so I can say that 54 is a little slightly up here, right? And I can say the time that match up with the first quarter can be 32 or 30. I'm gonna put it a little higher, 32. Because if I'm gonna draw it, it's gonna be like the same line or slightly higher. You go right here and then you come down. Let me use a different color. You come down. This is the same line. Can give you back 32 or 33 or so on. But I'm gonna use 32 to be on the safe side. So I'm gonna look for 165. Say it's gonna be right here a little bit. Somewhere right here. And I'm gonna put down my straight line. Right. And then put it right there. And I can say probably it's around 54. All right. So based on how accurate you don't have to be so accurate. But if you're very close and precise, they will give it to you. And so 54 minus 32, 22. All right. This one, the letters in the word positivity are each written on separate cards and placed in a bag. Darcia picks 2 of these cards at random with the replacement. Find the probability that she picks the letter I, then V. Let us see how much cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So that is out of 10. So, and then she picked I first. How much I's is there? 1, 2, 3. So that is 3 out of 10. And then they said V, right? So how much V is there? 1 V. So 1 out of 10. So it says find the probability that she picks the letter I, then the letter V. So we're going to multiply. So 3 times 3. 3 times 1 is 3. And 3 times 10 is 100. And that's our answer here. So at random, she'll be picking the cards 3 out of 10. 3 out of 100. And not bad. All right, moving on. Number 6. The diagram where we know pi equal 22 over 7. In the diagram below shows a gold bar in the shape of a transitoidal prism. Its volume is 2,886 centimeter cube. The length and height of the prism are indicated on the diagram. Now, it's asking us to calculate the area of the shaded cross-section of the trapezoid prism. Shaded. So right here is shaded. Good. So we know that uh, we have the volume that's what was given, and now we're trying to find the area. Now, volume is area times length. Now, we know the volume and we know the length. So all we have to need to do is find area. So area would be times the length, which is 1.2, equal the volume, which is 2,886, and then make A the subject and divide these two. Let's get back to our calculators. $92.5 centimeters cube, and that's our answer right there. Not bad. And that is 1 mark. All you have to do is remember your formulas. I believe it's also in the list of formulae. So if you don't remember it, you can go back to the first page and find the formula. All right, next, the cuboid shaped goal bar shows below has the same value as the trapezoidal prism shaped goal bar displays at A. All right, so to calculate the height of the cuboid shaped goal bar. Now let us remember the volume, which was about what? Mm-hmm. 2886. Good, we know what and then what we're finding is the height. So our volume, our formula for volume is length times width times height. So 2886 equal 30.6 times 8.2 times height. All right. Let's use our calculators. Let us multiply the 30.6 times 8. What do we get? 250.92. All right, times H. And we still have our volume over here. Now we're going to make H the subject. So H is going to be equal to the 286 divided by 250.92. We equal to what? Equal to 11.5 centimeter. Right. Okay. All right. Moving on. Hold on. Oh, okay. All right. So the prism gold bar is melted down and all the gold is used to make a 6 identical sphere. Calculate for each sphere of gold its radius, with the volume of the shape with the radius r equal v equal 4/3 pi r cubed. Hmm. Hmm. So the prism has been melted down to sphere, and we're supposed to find the radius. And they're giving us the formula for sphere, volume of sphere. All right, so first and first, we know the volume of the prism first. Good. And that was about hold on, let me go back. 2886. Good. Now, since it divided up into 6 identified, so this is the amount of volume of one sphere. So I'm finding the volume of one sphere right here. So volume of one sphere. All right, so our answer will be 2886 divided by 6, 481. So each sphere that's the volume. Now we're trying to find the radius now. So since we know the volume of one sphere, now we need to find the radius. So they gave us the formula right here. So I don't need to write that down back because we can see it. So 481 over 4/3. Or pi was what? Pi was 2/7. Times r cube. Okay. So I'm going to carry everything over here. So it's going to be 481. I'm going to flip everything because when you change it, you're going to divide. Or do I add these first? I mean, multiply these first. So it's easier for you to understand. Instead of to explaining that I flip it over because it changed the divide and we don't divide with fractions. So let us multiply these two fractions first and see what we get. We get our two fractions will equal to 88 over 3 times 7, 21. Okay. All right, times r squared. So I'm going to come over here and say 48 over 1. So since it's multiplying the r, I'm going to put 88 over 21 here equal r cubed. So we know what we do right here. It will be 481 times 21 over 8 equal r cubed. And that will equal to, r cubed will be equal to 114.78. All right. So in order to find r, we're going to cube root, right? So this cancel this, and we're going to cube root this answer right here, which equal to 4.86 centimeter. And that is our radius. Moving on. All right, so the next thing we're going to find is the square root of the sphere, right? That we're going to find the prism, but it's a sphere here. So the surface area of a sphere with the radius r, a equal 4 pi r squared. So we're going to write back the same thing, a. We know what the pi is, 2/7. And we just figure out what the radius is, which was 4.86 square. All right, we're going to use our calculators here. And our answer should be I got 297 centimeters square. All right. We're going to find the mass to the nearest kilogram, given that the density of gold is 19.3 gram per centimeter cube. So they gave us the formula here, so we don't have to run through our memory to find it. So we're finding the mass. So we're going to make mass the subject out of this formula, which is mass equal density, times volume. So that is our formula, rearrange. So we got the density, which is 19.3 grams per centimeter cube. And the volume again of the gold, and since we are using the sphere, it's 481. All right, so in our calculator, we should have the answer. Times 481. Answer 9,283 gram. That is gram, and they asked us to find it to the nearest kilogram. So the nearest kilogram, remember that 1,000 gram equal a kilogram. So this is 9,000. So it is 9,000 kilogram. So 1,000 gram gives you 1 kilogram. So this is 9,000. So it's 9 kilogram. And they said the nearest kilogram can be 10K. All right? All right, moving on. All right, so this says the diagram below shows the first four diagrams in the sequence of regular hexagon. Each regular hexagon is made using sticks of unit length. Can complete the diagram below to represent diagram 5, the sequence of the regular hexagons. All right, so based on the pattern, diagram 1, diagram 2, diagram 3, diagram 4. The pattern is that every time you add two more hexagon, so this was 3, and now this become 5 hexagon, and then this became 7, so you add 2 more, and 9. So that means the diagram 5 should have 2 plus 9 would give you 11. Now right here only have 1, 2, 3, 4, 5, 6, 7. 7. So you're going to draw your own hexagon here. It looks like, ooh, we have to have 11 of them. One more. And that is 11. All right. Next one is the number of regular hexagon, H, the number of sticks, S, and the perimeter of each figure, P, follow a pattern. The variables for H, S, and P for the first four diagrams are shown in the table below. Study the patterns of numbers in each row of the table and answer the question that follows. Complete the rows marked and I in the table below. All right. So let us see. So it says to find the pattern of each row. So let me see. So number 1, diagram number 1 has number of hexagon 3, number of sticks 15, and the perimeter is 12. So I am going to go down one like the column. Let's see. So the same thing we did a while ago. We realized that in here we add 2, right? So that means our diagram, when we add 2 to it, 9, we got 11. Okay, so the same thing here, right here. If we added 2, what is 15 out of 23? So we're going to subtract 15 out of 23, and that is 8. So that means I am going to add 8 coming down. Good. So 8 plus 39 is 47. And if I'm coming down here, it will be, I am adding 4. Good. So we find the pattern right there now. We found the pattern. So let us go on to the next row. All right. Hmm. Hmm. Okay, so before we go to that row first, let us go to N first before we start on the second row. All right, so it says N. We don't know what here is. So we know that it is 2. Right here, we know that we are adding, we're multiplying N. So N. All right, so hold on. Every time I go down, I wonder if I can make it bigger. Or I can, all right, so hold on. So maybe I can use this. All right, yes, there we go. No more issue. So we know that 1, if we add, if we say N times 2, so 2 times N plus 1 will give me 3, right? So 2 times 1 is 2, plus 1 will give me 3. That is my first clue right here. All right. Good. And then I can come down here and says 8, because we are going down by 8, times N plus, hold on, so 8 times 1 is 8. So 8 subtract 15 gives you 7. So 8 times N plus 7 gives me 15. And then 8 times 2 plus 7 give me 23. There we go. So that is the next pattern. And the same thing here, 4 times N, right? So be aware that the N is the number over here, right? So 4 times N plus N subtract 4 subtract 12 will be 8. So 8 will be over here. Good? Everybody all right with that? Now we don't know what N is over here. So we need to find. So all I can do is, since I know what is here, I can say 2N plus 1 equal 47. And I'm going to make N the subject. So 2N plus 1 minus 1, subtract 1. So cancel out, leave 2N equal 46. And then I divide. N is going to equal to 2, 3. So over here will be 23. So since we know that now, I can now use the 23 for this pattern right here. So I can say 4 times 23 plus 8. 4 times 23 is about, oh, wait a minute. It would be 50. Oh, not writing, that's the 52. And then plus the 8 will be 60. The answer will be 6. Hold on. Hold on. Something's not right here, so it's not 52. 92, yes. And this would not be 60, it would be 100. The answer is 100. All right, going next. All right, so it says, Skylar says that she can make one of these figures with a perimeter of exactly 1005. Explain why she is incorrect. Oh, we're proving that she's incorrect. So based on what we had over here, what did I say this was? 4n plus 8. All right, so 4n plus 8, that will equal to 1005. So we're going to make n the subject now. So 4n plus 8, subtract 8, 100 and 1005, subtract 8 will equal to 997. And then we divide by 4, cancel, n equal 249.25. All right, so she's not correct because this is not a whole number. All right. So in order for it to be correct, the n needs to be a whole number. All right, let's move on. All right, we reach at 8. Okay. The function f and g are defined as the following. All right. We love these. So g of 2, right by g2, wherever wherever the x is, we put 2. So 5 minus 2 squared, which give us 5 minus 4, give us 1. And that's our answer here. So the inverse of f, so we're going to put this in inverse first before we solve it. So I'm going to change f of x to y, 2x minus 1 over 3. So I'm going to interchange again. So no, y is going to be x, and x is going to be y. And now I'm going to make y the subject. So 3 is going to come over here. So 3x equal 2y minus 1. And then over here I have 3x plus 1, because we changed the -1 to plus, equal 2y. And then this is going to divide everything. The 2 is going to divide everything over here. And it will equal to y. So now I am going to use too much space right here. Three. Three x plus 2x, and then 3x plus 1 over 2 equal y. All right, so since we find the inverse now I can plug in f of x, negative x, of 3 equal 3 times 3 plus 1 over 2. So I'm coming over here, 3 times 3, 9, plus 1 over 2. And that is 10 over 2 equal 5. And that's our answer there. And that is 2 marks. Moving. All right, so it says derive an expression in the simplest form for g to x. FG. All right, so that means g is going to be in the equation of f. And let me go back and see what that is. So that is 2x minus 1 over 3. And g is 5 minus x squared. All right. So let me write that down. So f of gx equal 2. And wherever x is, I put g minus 1 over 3. All right. Now I'm going to use distributive law. 2 5s 10s. 2x squared minus 1 over 3. Then we have group like terms. 10 and -1 is 9. Subtract 2x squared over 3. And that's our answer there. Go cannot move along. All right, let's go on. All right, so sketch the graph of the function gx in the space provided below. On your sketch, indicate the maximum or minimum point and the root of the function. So the root of the function means I have to find x. So we need to find out what is gx again. Let us go back. Gx is 5, subtract x squared. 5 subtract x squared. All right, so we need to find out what x is. So if I can make my equation equal to 0, remember from this morning, yes? When our equation equal to 0, so I am going to bring over my 5 from positive to negative. So that is 0 minus 5. And this will be negative x squared left. And we know that this is negative 5 equal negative x squared. Hmm. Then I am going to find out what x is by square rooting. So if I square root this, right, I get x. And if I square root the 5, I will get positive or negative square root. So what is square root of 5? Right. 2.2, positive or negative. All right, so we find out what x is. Now we need to find the maximum and minimum point of and we know that maximum and minimum point is parabola, and it's always on the y-axis. So mm, oh, hold on. Let's see if I can add another slide right here. I can't add another slide. So let's see. All right. So using the equation of a line, let's just go over here. So it is y equal, I'm going to switch these around. Negative x plus 5. Good. Still going to find out what x is. So we know that x can be equal to negative b over 2a, right? And negative b, we don't have any b right here, so that is 0. And we know that 2a, 2 times 1. So 0 divided by 2 times 1 will always give you 0. So x is 0 in this equation here. So I'm going to substitute it for 0. So y, substitute for 0. Oh, this is supposed to be square. Plus 5. You know that equal to just 5. So that will be our maximum point. That's how we find our maximum point. y equal maximum point. So I am going to jot down and make a sketch where 5 is my intersection or maximum and midpoint, and x is 2.2. All right. So I am going to put 1, 2, 3, 4, 5. So 5 would be right there. Change the color. 5 would be right there. And then we get back our color. This would be 1, 2, 3. This is -1, -2. We know that the other part is 3. All right, so let us put in our x value, which is either positive 2.2, so that's going to be right here, and negative 0.2 will be right here. All right, so let us draw our parabola. So we go from here. It's just a sketch, so it doesn't matter how you do it, just make sure that it is accurate. There you go. And that is about how much mark? 3 marks. All right, moving on. All right. B. So it says the graph below shows the quadratic function on the grid above. Draw a tangent to the curve at x equal 1. Where is 1? Oh, here is 1. So x equal 1. So the tangent has to be right here. Now I am going to use a line to draw it right here. So I'm going to put it here. Therefore, that's the tangent right there. All right, so that is my tangent in red. So check, that's 1 mark. Next one, use the tangent drawn to estimate the gradient of the curve at x equal y. So I am doing a gradient. And with the gradient, I can do a triangle right here. Good. So stop right here. And I'll go across right there. And then I'll do a triangle. Good. So we can have a rise and run situation right there. So over here will be 1, 2, 3, 4, 5. So 5. 5 rise All right, so our gradient, let me write G for it, is rise over run. And we know that from here to here is 1. Good? On the scale. According to the scale, from here to here is 1. So this is going to be 1. So that is 5 divided by 1 will give you 5. So our gradient is 5. So you have to look at the scale because they can trick you. Even though you're counting by boxes, you have to realize that right here is 1 on the y-axis. And on the x-axis, I mean, 1 on the x-axis, and on the y-axis, they had from 0 to 6. So there are ways that they trick you. So you have to really pay attention to what is going on. All right, so that is... Next one, we have write down the equation of the tangent in the form y equal m, x equals c. So we know that m equal to 5, right? So let me see if I can go back. Oh, it's all gone. All right, hold on. Okay, so bring it back there. Ooh, I can use this line right here to extend the tangent. And you can see right here that I cross the y-axis at -2. That is what C is. So C is where you cross the y-axis. So I see that I cross it at -2. So based on how you draw your own, you can strictly get it correct. So now I'm going to write my equation as y equal 5 x plus -2. See, 1 mark. You don't have to do no calculation right there. You can just, based on your graph, just get the answer. All right, next, we have our circle theorem. Okay. This is going to take a little while. A circle theorem is something that you have to grasp. You have to know the rules. If you don't, you won't get it correct. So we can take our time right here and come up with some theories because they don't give you in the list of formulas. So you have to know the circumtheories by heart. All right, so let me see if I can pick up like a circle theorem paper so you guys can view it. All right, so I'm downloading it and I'm going to send it your way. Oh, I wasn't talking the whole time. Why nobody ever said me I'm not talking? All right, so let me repeat that again. All right, so but I basically wrote it right here. So angle B equals 62. So basically, if the angles are coming off from the same arc or chord, they're equal the same thing. So the B is gonna equal to the 62. So they're coming off from the same arc. So this is the same arc they're coming at. Let me draw it. The same arc. This is the same arc they're on. Okay? And they're in the same segment. So they must equal the same. Okay? Let me erase right here. So that is it. moving on to somewhere else. Angle C equal 127. So angle C, where's angle C? Angle C is right here. It's at the center. It's at the center. All right, so if angle C is at the center, that means dun, 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 dun. Well, let me check. If angle C is at the center, all right, so here's the theorem. If angle C is at the center, that means it is twice the angle at the circumference. So this is the angle at the circumference, which is it's the 2. So can somebody please multiply 62? Oh wait, I can do that. Multiply 62 by 2. Ah, there we go. Yes. So yeah, that's correct. That's the theorem. So let me just type this right here. So angle C is at the center. So it is twice the angle at the circumference. Right. So, and 62 times 2 is 124. So make a jot of that.
Excuse me.
Yes.
I'm going to step away for a bit and come back.
All right, no problem, Rahim. All right, so let's just skip this through. Done that one. All right, so we have angle OVW. All right, hold on. Let us wait till Rahim comes back. All right, so we're finding angle OVW equal 90. Are we going back? Uh, W, W, O, oh, O is right here. V, W. That almost look like a right angle. But we need to prove that it is a right angle. We can't just say it's a right angle. We need to prove it. So we need to see where we can get. All right, so we say right here, so right, look like a right angle. So because this right here is a radius, good, and a tangent right here, that's our formula. That's our theorem that any angle between a tangent and a radius is 90 degrees. Mm-hmm. Eh? Well, since we already know how to do it, just continue. All right, moving on to the next one. All right, so it says here, find the value of angle ADE and show all working where appropriate. All right, we know so here's 90. We know right here is 62, or we know right here is 124. So angle A is the first one, right? All right, so we know that the tangent, the entire tangent is out of 180, right? And then hold on, let us go through the theorem again before we. All right, so that theory. Look for the tangent, right? Right here. From a 90 degrees angle, good. And it's right beside a chord. So this is the chord. Just beside the chord. Okay, so I know what it is. All right, so because this is a chord, Good. And the angles right next to the chord is going to equal to the alternative angle in a alternative segment. So it's equal to an angle in an alternative segment. So the angle in the alternative segment is this 62. So A is going to equal to 62 degrees. Why? Let me type that. So it is any angle at the chord equals to angle in the opposite or alternative segment. Right, and that is a theorem. All right, so the next one should be what again? Angle D and then E. Okay. Angle D angle D. Where's D? D's right here. So all right, so we know that C it was about like what 124. Good. We know that A is 62. So what we can say is that I can say that probably this triangle right here, right? Where you see ZOV, it looks like an isosceles triangle, right? And you know that isosceles triangle, the two angles are equal, right? So this D is going to equal to that. And we know that one side is 124. So I can say that 180 subtract 124. And since me know say two sides, two angles are equal, I'm going to divide it by 2 and see my answer. Let me see. That is 180 subtract 124 divided by 2. And that is 28. So D equal to 28. D equal 28. So please write that down. And please note that the recording will be sent in the WhatsApp group. All right, so recording will be sent into the WhatsApp group. So please rewatch it, and if you can, write down the notes. All right, so the last one is what? E? Last one is E. All right, so we know that this is 28. Know that this is 28. We can see that Oh, okay. I get it now. All right, so back to what we're saying again. Angle at a chord equal to the alternative segment, the angle at the alternative segment. So right here now is 90 degree, right? And I minus 90 degree by 18 degree, I get 72. Good. So that's not the answer yet for E, as is the answer for here. So here, from here, so right here to right here is 72. Good. And we know what D is. D is 28. So I'm going to subtract 72 minus 28 to give me E. And that will be how much? 44. So that is E. So that is it for E. And this has to do with a lot of practice, a lot of memorizing of the theorem, and a lot of assuming and learning the properties of a triangle. So much circumtheorem is about. So it's a lot of practice to go through. So I hope that you work hard on circumtheorem. A circumtheorem is not going to come easy. All right, so moving on, we're going to number 10. Is this number 10? Oh, we reached 10 yet. Okay. This is the diagram below shows a quadrilateral PQRS formed by joining two triangles, PQS and QRS. Calculate the length of QR. So QR, the length of QR. So this is right here. Check the length of QR. And it says it's a form of two triangles. So we're going to use our sine rule, cosine rule, which you can find once again in the first page of the list of formulas. Okay, see it here, see it. The cosine rule, because we only have, right, so this is the formula for the cosine rule, which is QR equal QR square equal B square. So let me write this over here. So it's going to be A square equal B square plus C square minus 2BC cos theta. All right. So once we get that, so 16 square plus 18 square minus 2B. 2B is 16 and C is 18 times cos 25. All right, so let us go through all of that. Let's use our calculators and find that answer there. So 16 square plus 18 square times cos 25. And that gave me about, oh wait, I forgot something. Times 2 times 16. Oh, I need to subtract. My apologies. I am feeling the tiredness already. Times 18. All right, then I got 50, 58. And now I'm going to square root that. 58. Square root 58 give me 7.6 m. So QR is 7.6 m. All right, moving on. The bearing P from S is 205. Determine the bearing of R from S. P from S. So I'm going to put my compass right here in. And then from S to P right here is 200. So we're going this way, right? So all of that is 205. That's what it says. 205. Okay. So you're supposed to determine R from S. Okay, so that means right here. Okay, so all I have to do now is add up 72 and 25. So add 72 plus 25 will equal to 97, and then subtract it from the 205. And we get 108. And that's our answer right there. That's our bearing from R from S. And then we're going to calculate from S from P. So we're going to put our point at our N at P. And from S, let me make this space out a little bit more. So from P to S. So from the P. All right, so right here is what we're trying to find. Hmm. All right, so if over there so is 205, all right, so if over there is 205 and we found out that right here it's 108, um 108 and the entire place right here, everything right here is going to be subtracted from 360. So I'm going to subtract. So right here is 360 from 205 gives me about 155. 5, good. That means 180 subtract 155 will give me the answer. 180 subtract 155 will give me 25 degrees. 25 degrees, so that means this is 25 degrees. All right, this is the last question, number 10. Easy peasy vectors and matrices. All right, so it says the determinant of matrices is that is 24. Calculate the value of V. And we know that the determinant is AC minus BD equal the determinant. And the determinant is already given to us. So 24 equal A is 6 times and C is V. It's negative V. Negative V. And subtract B is 2V and times D, which is negative 5. So let us put these together. So 6 times V is negative 6V. Subtract 2V, 5, 10. So positive 10. V equal. So it says 10 minus 6, 4V. All of that equal to the 24. 24. So V equal 24 divided by 4, which gives you 6. And that's our answer there. So V equals 6. All right, next one, the matrices L and M are defined as the following. L equal 9, 3, 5, 2. Give me a minute. All right. Evaluate each of the following, the matrix product LM. So you're going to multiply the two products. So that is 9532 times 2 negative 4. And we know that it is row times column. So this row, first row times the column, 9 times 2 plus 5 times negative 4. The second one now, 3 times 2 plus 2 times negative 4. And we proceed, and we find the answer for this one. 9 times 2, 18, plus 5 times negative 4, 20. So 18 plus negative 20, negative 2. 3 times 2 is 6, plus 2 times negative 4 is negative 8. So 6 plus negative 8 is negative 2. So this is our answer right here. All right, L inverse, we know our pattern. The formula is for L inverse should look like this. L inverse should look like 1 over determinant L. B all right. D, negative B, negative C, and A. All right. So first and first, let's find our L determinant. And going back over here, our L is 9532. 9532. So our D is not, our A is 9. Hold on, let me write it right as well. 9, 5, 3, 2. Right. So 8 times, so 2, so 9 times 2 minus 5 times 3. So that is 9 times 18 minus 15 will give you 3. So our determinant is 3. So this is how it looks, 1 over 3. And I'm gonna put my A, my D is gonna be up here, so 2 is gonna be up here. 5 is gonna be negative 5. 3 is gonna be negative, and A is gonna come down here. So this is how it should look like. And that is 2 marks. All right, next one, vectors. Vector PQ equal 5, negative 4. If P is the point, negative 2, 3, determine the coordinate of P. Now, using our knowledge of PQ, we will assume that P is coming from our original. So this is PO, vector PO plus OQ. Or I can sketch it like this. And we say this is P, and this is Q, and this is O. It don't have to be O. You can write A or whatever. Well, that is a vector in visual. All right, so we are trying to find Q. Then I'm going to make Q the subject. So Q, OQ is going to be the subject. And I'm going to put PQ here, subtract PO. All right, so that is 5, 4, subtract PO. I'm going to flip this to make it look like a vector. And my answer will be 5 minus -2, 7. And -4 minus 3 is what? -7? Is it -4, right? Yeah, so -7. So that is our answer. So 7, -7. All right. In the pentagon, OABCD, OA is parallel to DC and BAB is parallel to OD. OD is equal to 2AB and OA equal to 2DC. Vector OA equal A and vector AB equal B. So find in terms of AB in the simplest form, vector AD. So the same thing here, we're going to look for vector AD, but there's none. They don't show no line. So I am going to place a line right here because I'm a visual learner. I have to make sure that I am able to see all the lines and how they connected. So AD, I'm a visual learner and a tactile learner, right? So what I'm seeing is from O to A plus O to D makes up AD. That's what I'm seeing there. Now, OA is A, right? But look at it. I have turned it around. It's now AO. So now my A is going to change from A to -A because it's going into the opposite direction. And OD is supposed to be 2AB, which is 2B. And AB is 2 is B. There we go. So that's it. Finish there. All right. Vector BC. All right, so I'm going back to the diagram and looking for BC. See it right here. This is BC. All right, so what's making up BC now is BA, so vector BA. So we're going this direction and AO. All right, I'm back. All right, so the recording is still in progress. All right. So here we go. All right, so we left off with, what was it again? AO. And then I go from O to D. Then I am going from D to C. There we go. All right, so what they say BA is about again now. So it's B. So because it's going to the opposite direction, the B is going to change to negative B. OA, as we acknowledge, was negative A. OD was 2B. And then DC was DC, where's DC? DC was this is the only thing I see DC in. So DC is gonna be, if I use this, I have to make DC the subject. Good? So that means my 2 is gonna come over here. So it's gonna divide OA by 2 to give DC. So that means half of OA is DC and half of OA is what? A. So in order for me to write that now, I'm going to write it as half of A. Half of A is DC. Good. Now let us simplify it now. Let's combine like terms. Now let me rearrange the negative A plus half of A minus B plus 2B. Let's see. So negative A plus half of A is basically negative 1 plus half is subtracting. So it's going to be negative half A. And then negative B plus 2B is going to just be positive B. So that's our answer. Or you can switch it around and say B subtract half of A. So either one is correct. All right. Moving on. This is the last question. Last of last. So it says, state the conclusion about vector AD and vector BC that can be joined from your responses in I and II. So we're going back around and we're going to look for vector AD, and vector BC. So this is AD, this is negative A plus 2B. I'm going back to BC now. BC is B minus half of A. Oh, okay. So based on this, we can say that it is parallel, right? You see, that's why it's good to draw. So we can observe that it is parallel. It is parallel. And we can say, based on the two things, that A right here and A right here is half A. They say half A, right? And over here is a 2B. And over here is a B. So that means BC is half of AD. I can say that. Or I can say AD is twice BC. So let us make a note of that. So AD and BC is parallel. And we can also say AD is twice BC, Or BC is half AD. Any one of them and you're correct. And that is the 1 mark. And with that, we're finished 2024. And that took us about 3 hours and 22 minutes. We had so many challenges. We got shut off and came back on again. All right. So I hope we understand. And for those, let me stop the recording. It don't seem long.